optimizing the fan coil unit speed and finding out the optimal start and shut off of the HVAC based on the zone level. So I have worked with CFD, and I have made a lot of scenarios. And for those who works with CFD knows how complicated and how does it take a lot of time to generate different scenarios. But what I have throughout my research, I don't know what closes the which one? Okay. So the computational time was very big because I have made hundreds of scenarios to optimize the speed of the fan coil unit with respect to the thermal comfort of human, which is the temperature, speed of air inside the room, and of course the humidity. So taking into consideration all of this, I have made hundreds of CFD models using, of course, data that was a whole system that was getting sensors reading. I have validated my model, but actually I had during this model a lot of missing data. Sorry for that. I had a lot of missing data from the CFD. So computational flow time was very big, and I had a lot of missing data from the CFD model. So the best way was to use machine learning to compensate these missing models and to accelerate the process of the CFD by giving indications about the results of the CFD simulation. So I have used different machine learning models. I'm going to show you the results of each one and which one was the best in terms of results. Of course, this is the classwork that we have worked on, and we have did the mesh independent test to find the best results and accuracy of results. And here's part of the results which you can see the velocity contours and the temperature contours here. And you can find here the number of people who are dissipating heat. And this is, of course, the outer temperature. And here's the temperature contours. Here's the velocity contours that we have done. We have hundreds of this CFD results. Of course, to understand exactly the temperature, we have calculated the volume mass flow rate of the total temperature for this one to find exactly the specific temperature of the whole room. But at the end of the day, we have found out that we have different number of people, like 0, 2, 4, 6, 8, 10, and we have different actual temperatures inside the room that it changes with each flow rate. So as I was telling you that I am optimizing the fan coil unit speed, so I need to find out which is better with each scenario, and with each scenario with the outer temperature that we are working on. So we have got out a lot of data, but we have also missed some. So I use the machine learning to frameworks to find out the best solution. Here's the temperature validation also of the model. You can see the change of temperature from the supply in the beginning of the day. Here the temperature is decreasing because this one was put in the inlet or the supply of the HVAC. And so you can see exactly how the zone temperature supply is being changing. And this was used for the validation. And here is a machine learning framework. I have started by the linear regression model, but unfortunately, the missing part was given a very bad accuracy, R squared equals 0.4. And you can see here the data with the missing parts of it. And here is the predicted data, which is not fitting with the curve. And then I have used the multiple linear regression, and it has produced a better results, but not as what we were expecting. It has produced R squared equals 0.5, which is better than a linear regression, but it's not what we were looking for. And we have used also XGBoost, which have improved the R-square to 0.62, which is somehow better, as you can see the fitting of the missing data compared to the actual ones. And then we have used the ANN, which shows the best results at all, with accuracy around 98%, which was amazing to use. For those who does not understand what's artificial intelligence about ANN model, I'm gonna give you like an analogy example to understand how does it work. I'm not a biology researcher or computer science engineer, so I'm gonna give you like a brief analogy example about it. Imagine this is a cell body. The cell body is like a company, and it has a lot of inputs. The dendrite, which is the main box of the company, and this dendrite receives a lot of requests or emails that go to the company. And there are a lot of workers in this cell body. Each one vote for yes or no for the requests they receive. And finally, this goes to the manager, which is the Axon, who decide based on the vote that he got over each request either to accept it or not. According to the workers, each one is having his own role, either a junior engineer or a senior or a manager. So each one should be given a specific weight to find out the results from the Axon, which then is sent to the other neuron, which is another company, to re-evaluate the results. This is exactly what happens with the ANN. We have inputs and we have weights for each input, which defines the function which produces the output signal. And the good thing, also of course, I have used different hidden layers, started by 1 and 2 and 3, and 3 has produced the best accuracy for the model. And you can find here the results and the missing part, which is actually fitting exactly over the results that we were looking for, producing R-square, which is 98%. This is the validation sensor, which I have showed you the graph, which was used for validating the CFD model. And we recommend using the same machine learning model on different geometry models to validate the R-square which we have received, also to integrate it with the MPC powered HVAC system, and also to use an ensemble machine learning which integrate the linear regression with the ANN to improve the R-square. This is what we have done, and thank you for